ways you could solve this one. First of all, do you see how you're missing the x? That's personally how I solved. Also, you could have solved using the quadratic formula, but let's do it solving the x. Everybody pay very close attention to what I'm about to do. You have to be able to do problems like this. So firstly, we isolate x squared, right? So we add 2. So we have 3x squared is equal to 98, right? Then we divide by 3. So we have x squared is equal to, if you type that into your calculator, you get a decimal. You change it back to a fraction, and you get 98 thirds. Is everybody comfortable up to here? How many got that far? Okay, good. So the next step, take the square root of both sides of the equation. And our root cancels out our power. We have x is equal to plus and minus the square root of that. You get a decimal, so you won't do it. You'll remember this. Don't you remember that we learned that we split it up? We learned that. So you split it up. Isn't this the same thing as the square root of 98 over the square root of 3? Isn't this the same thing as this? Then from there, is this answer acceptable? No. No, don't we need to rationalize the denominator? It's not okay to have a radical in the bottom of our fraction. So we'll multiply by the square root of 3 over the square root of 3. Now look, everybody close attention. On top, we're multiplying two things that are both under a square root, so you can multiply them together. So on top, we have the square root of 98 times 3. Does everybody understand that?
Wait, why did you do square root of 3 on both sides?
Because we need to rationalize the denominator, meaning you can't have a radical in the bottom, so it's going to fix it. So see how this is the square root of 3? We're going to multiply by the square root of 3, but if you do that to the bottom, you've got to do it to the top, because then you're just multiplying by a fancy 1. So on top, you have 98 times 3 under the square root. Does everybody understand that?
Good.
And on bottom, don't we have the square root of 3 times 3, which is 9? Good. What's the square root of 9?
Good.
3. So does everybody see how that took care of the radical in the bottom? Now from here, you would go off to the side and say, I'm going to break that down. So I'm breaking down the square root of 98 times 3. Now, the reason I'm not multiplying it together is because when I break it down, you'll break it back apart. So we have a 3. What's 98 break down into? 49 and 2, right? So it breaks down into 49 times 2, and then 49 breaks down into 7 times 7. Now, because it's a square root, we're pulling out groups of 2. There's 2 7s, so a 7 can leave the house. Can the 2 or 3 leave? So we have 7 square roots of 6. So our top became 7 square roots of 6, and on bottom we have a 3, right? And then there's nothing we can do. And we just don't forget the plus and minus. So some of you are close, some of you way off. A difficult problem, but can you do it in the future now? Yes? Okay. All right, so one other thing, notice how if you read the directions, because this is a problem that was on the end of level last year, it said, which value of x is a possible solution? So you could have put, if it didn't say find the solutions, right? It just said what's a solution. So you could have used either or on this one and got it right. Does that make sense? If you plug in either of those answers, you'll get it right. Okay, questions on that? But on the end of level test, if it said, what are the solutions, you have to have both or you get it wrong. Some of you came in and retested, you forgot plus and minus again. Yikes. Okay, any questions on that? Okay. Let's get to what we're learning today. So, you guys, you focused in on exponential functions in secondary math 1. It's one of the biggest focuses in secondary math 1, are exponential functions. In this class, we were comparing linear, quadratic, and exponentials. So today we're going to kind of focus in on graphing exponentials. Alright, so exponential functions, guys, look like this. Now look, they start out either really, really small. You see how this problem starts out really, really small and it gets exponentially larger. Yes. Alright, and then with this one, it's starting out really, really small and getting exponentially smaller. Does everybody see that? Okay, exponential functions have this form. You'll want this written down somewhere in your notes. So exponentials have the form y is equal to a times b raised to the x. Now this is a parent function, meaning non-shifted function. They have this form. Y equals a times b raised to the x. Now a couple things before we get into what a and b is. See how it's written like this. Y equals a times b to the x. X is in the exponent. Now b is the only thing being raised to the x. I'm going to say that again. B is the only thing being raised to the x power. Now you might see it written like this. Y equals a times b to the x, where b is in parentheses. Either way, they mean the same thing. It's just written a little differently. Is everybody comfortable with that? Okay. A is the initial value. So the initial value, kind of the starting point. And if you have a non-shifted function, it's when x is equal to 0. As long as it's a non-shifted function. So we can plug in 0 in for x, and that would be your initial value. Now look, here's why. So we can just look at that value and say, oh, that's my initial value. So if this was 2, our initial value is 2. But look, if we plug in 0, we'll get a. What's b to the 0 power? 1, right? What's a times 1?
1.
What's a times 1? A. So you see how the initial value is just a. And it's when x is equal to 0, as long as it's non-shifted. Okay, b is your growth or decay factor. So it's your growth or decay factor. What you multiply, a factor is always multiplication. So that's our growth or decay factor. You know it's growth if your b value is greater than 1. So it's going to be exponential growth if your b value is greater than 1. If your b value is less than 1, it's exponential decay. If your b value is less than 1, it's exponential decay. Any questions on that? Okay, let's just determine on these if our initial value, if it's growth or decay. So looking at this one, what's my initial value? 3, guys. Your initial value is 3. What's your factor? 2. Is it growth or decay? Growth, because 2 is greater than 1. Does everybody understand that? We're just getting comfortable with the exponentials today. Well, careful on this one. What's my initial value? So I hear two good things. So some people are saying 0, good thought. Some people are saying 1, good thought. So if we put a 0 here, let's think about it. Like 0 times 4 raised to the x, isn't that 0? Yep. So we wouldn't have 4 to the x. So good thought. But our initial value is indeed 1, because 1 times 4 to the x is still 4 to the x. So it goes without being said, there's a 1 there. So our initial value on this one is 1. Questions on my initial value on that one? Is this growth or decay? Growth. 4 is greater than 1. Our factor was 4. Okay, looking at this one, what's my initial value? Negative 2. What's my factor of 4? So is it growth or decay? Growth. Okay, awesome. Initial value?
1.
Good. It's 1. It goes without being said. There's a 1 there. My factor is a half, so it's decay. Good. Initial value is negative 4. Now careful. Growth or decay? This one's there to throw you off. It's growth, right? Even though it's a fraction that comes out greater than 1. It's 1.5, right? So this one is meant to throw you off. This one is growth because that's 1.5. And then with this one, our initial value is negative 1, right? Everybody?
Right.
And then it's decay because 1/5 is less than 1. Questions on that? I said growth, but I meant decay. Okay.
Wait, so it has to be bigger than 1 and not be the initial value?
Yes, good question. For growth or decay, you only look at the factor. So not the initial value at all. You only look at the factor. So this negative has no effect. We only look at this. Yes. Yeah. Okay. So let's practice graphing. So with an exponential graph, we're first graphing parent function, which means non-shifted function. So we're going to graph this one, y equals 2 raised to the x power, okay? So guys, when graphing anything that's non-shifted with exponential functions, we have an asymptote at y is equal to 0. So everybody, do you see this red dotted line on the x-axis? That's my asymptote at y is equal to 0. Now, an asymptote is a value that your function gets really, really, really close to, but never ever crosses. So I promise, if you plug in any value for x, you will never get 0. You're going to get something that gets really, really close to 0, but you'll never get 0. So it's going to get exponentially closer and closer to that asymptote, but it will never cross it. Does everybody understand? So if you have a graph crossing it, you've drawn it wrong. It will never cross your asymptote. Okay, so a non-shifted function starts at 0, 0. So we're starting at 0, 0. Let's just plot a bunch of points. So starting at 0, 0, let's plug in x is equal to 0. So I'm going to make an XY chart. If we plug in 0, isn't that our initial value? So we know we're going to get what? What's our initial value? Isn't it 1? Right? Isn't it 1? But let's plug in 0. What's 2 to the 0 power? Nope. What's 2 to the 0 power? 1. So at 0, our function's at 1. Does everybody understand that? At 0, our function's at 1. We plugged in a 0 and got 1. Therefore, we're at 0, 1. Does everybody understand that? Yep. Now I need you, our initial value, that will be your initial value. Look, wasn't our initial value correct? Wasn't it at 1? Okay, awesome. So now let's plug in some more values. Let's plug in 1 and 2. So I'm going to plug in 1, 2. So let's plug in 1. What's 2 to the first power? 2 to the first power is 2. So, I said, okay, so we're at 2. So we go over 1 up 2. Okay, now when we plug in 2, 2 to the second power is 4. So we're going over 2 up 4. Let's plug in 3 for kicks and giggles. 3 plugged in, 2 to the third power.
8.
So over 3 up 8. Okay, now let's plug in some points to the left. Now I want you to notice something about the exponentials. This was our factor, right? 2. Weren't we at 1? What's 1 times 2?
2.
What's 2 times 2?
4.
What's 4 times 2?
8.
So do you see how this is working?
Yep.
Okay, so now to the left, we're going to be getting smaller here. Let's plug in -1. So plug in negative x, y, we're plugging in -1. What do you get? 1/2. So we're going to -1 up 1/2. Let's plug in -2. 0.25, right? So we're going to -2 up 0.25. Now if you keep plugging in, it's going to get smaller and smaller, closer and closer to 0, but it's never going to cross. Now look, didn't we divide by 2 every time to get over here? We were at 1. What's 1 divided by 2? 0.5, right? Divided by 2 is 0.25. All right, so now we can draw in our exponential function. But do you see how we're just literally plotting a bunch of xy points? It's not hard by any means. Okay, questions on that one? Let's do another one. I'm about to choke to death. First of all, this is a non-shifted function. What's my initial value? It's 2. What's my factor? 1/2. So isn't it decay? Okay, awesome. So let's go ahead and plot some xy points, starting with 0. We plug in 0, plug it in. What do you get? You get 2, which makes sense. Our initial value is 2. So from 0, we're going up 2. Now let's plug in 1. Plug in 1. 2 times 1/2 raised to the 1 power. Type it into your calculator. What do you get? 1. So we're going over 1 up 1. Plug in 2. What do you get?
0.5.
0.5. Good. We'll do decimals, so that's a lot easier to grasp. So I'm going over to 2 up 0.5. Now, isn't it getting smaller and smaller by 1/2? Okay. So I'm going to keep drawing. It's never going to touch 0, though. Now let's plug in -1. So -1. X, Y. What did you get when you get -1? 4. So we're going to -1 up to 4. Plug in -2. You get 8. Good. Now look, we can draw in our exponential function. Now look, isn't it exponential decay? Didn't it start out, we look from left to right, we read it like a book. Didn't it start out really large and get small? So it's exponential decay, which makes sense. But we're just plotting xy points, guys. Don't get so caught up in all the logistics of it. Like, you know what I mean? We're literally just plotting xy points. Okay. Do we need to do another one that's like, okay, one more. Okay. So looking at this, it's a non-shifted function. What's my initial value? -3. So that's when x is equal to 0. So really we're just plotting xy points. Plug in 0, you get -3. So over 0, down 3. Now let's plug in 1 and 2. Go. Plug it in.
6.
So you got -6. Did anybody else get that? So we're going over 1 down to -6. And then what else? -12. So it's off my graph. Somewhere clear down here. Now let's plug some negatives in. So x, y. So plug in -1. -1.5. So we're going -1 down 1.5. Plug in -2. -0.75. So we're going to -2 and then down 0.75. So that's close to 1. So then it's just going to keep getting closer and closer to your asymptote. You see how this is working here?
How is it 0.75?
-0.75.
Yeah.
You plug it in. Use your calculator using parentheses. So you have -3, and then times 2 raised to the -2 power, and you get -0.75. You just calculate it in your calculator. Because think about it, if we have a negative exponent, it flips it over a fraction. That's why it becomes a decimal. Okay, so then we draw in our exponential here. Okay, questions on that? Now this is the last part. We do need you to state the domain and range. So let's state the domain and range on each of these. What's my domain? Look, isn't it growing this way forever? This way forever. So isn't my domain negative infinity to positive infinity? Or all real numbers. My range is y values. The lowest y value to the highest. Where does it start? Y values.
It keeps going.
Y values.
0.
0, right? Didn't our asymptote, didn't it get really close to 0? Right, it never touches it. So it's still getting really close to 0, but we can specify that it doesn't include 0 by putting a parenthesis.
So it's always going to be the same?
Yeah, for non-shifted functions. So it's 0 and grows to positive infinity. Now because you're right, it never touches down at 0, we put a parenthesis. If it included 0, that's when we put a bracket, right? Okay. So looking at this one, is that my domain negative infinity to positive infinity?
Yeah.
So all real numbers, and my range is 0 to infinity. Does everybody see it? I can't tell. And then with this one, my domain, this one's going to be a little different, but isn't domain from left or right growing from negative infinity to positive infinity?
All real number.
Okay? And then my range is y values. What's my lowest y value?
For sure. Oh, negative infinity.
It's growing to negative infinity, right? And then it's approaching 0. So negative infinity to 0. Right? Do you see it? Okay, you're ready to go. 1 through 6, go. Make sure you state the domain and range on those.
Oh, Brendan, good job.
Okay, so far we've been dealing with all non-shifted exponentials, parent functions, which means non-shifted exponentials.
Yes.
So now we're going to be talking about transformations of exponential functions. So if you have a transformation, there's going to be a few differences in your equation. So we know the equation of a non-shifted function. I'm going to write this down this time. The equation that we've been looking at is y is equal to a times b to the x. This is a parent function, non-shifted function. Now notice, this is the same thing, the shifted function, a times b, but now our x has something added or subtracted with it. Does everybody see how our x has something added or subtracted with it? So we have a times b raised to the x minus h. Now anything added with x, pay very close attention. Anything added with x is your shift left and right. So it takes your function and it will shift it left and right if it's added with x. And you always go the opposite of the sign. Anything added with x is the shift opposite with the sign. So if this had x minus 2, we would go right 2. Does everybody understand?
Yes.
Okay? And then this, anything added on the outside of your function. So we have plus k. So it's added on the outside of our function. Does everybody see that? This is your shift up and down. So it'll take your exponential function and it will shift it up or down. And your sign will stay the same. So if it said plus 3, we would shift it up 3. If it said minus 3, we'd shift it down 3. So think about it, guys. If we have a non-shifted function, yes. Okay. So if we have a non-shifted function, our asymptote's at 0, right, everybody? Now if we take and move and shift our function left or right, but no up and down, doesn't our asymptote stay the same? But let's say we take our graph and shift it up 3. Now hasn't our asymptote moved up 3?
Yes.
So this is going to change your asymptote, but only this piece. If it's just a shift left and right, it won't change your asymptote. But if you do have a plus k, it's going to shift your asymptote up or down that amount. So you would need to draw that in. And then your origin, your new origin, so with a non-shifted exponential, our origin was at 0, 0. So our origin was at 0, 0. But now with the shifted function, your origin will be at the shift left and right, shift up and down. So it'll be at h comma k. So, yeah. But we're still just plotting a bunch of x, y points. Yes. Yes.
So the x minus h is like plotting a circle. It's the opposite of.
Exactly. So you're right, because it's added in with x, it is shifted left and right, just like our circles. Absolutely correct. And that will work for all functions. Shift the same. Good point. Okay, here we go. So I just want you to tell me what's the shift on this one. Go. What's the shift?
-1.
Nope.
1.
Left. Isn't this our shift left and right, people?
Yes.
So this is a shift left once. Now, so isn't our asymptote still at 0, 0? I mean, isn't it still at 0?
Yeah.
We just took our function and shifted it left 1. Our asymptote still is at 0. Does everybody understand that? Okay, what's the shift? Right 2 and
Up 3.
up 3.
Down 3.
No, you don't go opposite of anything added on the outside. Yes?
I'm so confused on the being shifted. It's
I do
like,
that. Yeah.
so it's like,
If it's
yeah, like,
why does it go left?
That's just how it works. I promise. If you plug in the values, it'll shift all of those values back 1.
Then it's sticking to feet.
Alright, that doesn't make sense.
I can see why, but it works the same for all functions. So like, remember with quadratics, if we had something like this, y is equal to x minus 3 squared plus 5, we shifted right 3 at 5,
Oh yeah.
right? So it's the same thing. Anything added with x is the opposite,
Wait, so left
and
and right?
anything, this shifts it left and right, and this shifts it, anything added on the outside shifts it up and down. So it's the same way for all functions. Yeah, good question.
Wait, so the plus 3 is the left and right.
No, anything added with x is your shift left and right. You go the opposite, so we went right 2. Anything added on the outside is your shift up and down, so we went up 3. The sign stays the same. Okay, with this one, what's my shift left and right?
It's
0.
0. There's no shift left and right, but we are going up 4. Does everybody see that? So our asymptote will be up at 4. Ding, 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 ding. So with this one, our shift is left 1 and down 4. Okay, is everybody kind of comfortable with that? But still, nevertheless, let's say you didn't know that. Couldn't you just can't you draw a graph by plugging in a bunch of x, y points anyway?
So what if it's a negative x?
If it's a negative x, then you plug in x, y values and plot the function. So it'll make negatives positives and positives negatives. Okay. So here's my example. Oh, okay, what about this one? Is there any shift left and right? Is there anything added with x?
Yep.
Nope, it's multiplied to x. It's not added with x. So this isn't going to do anything but reflect it on the y-axis. Because let's say we plugged in negative 1. Won't that just make that positive 1? Negative of negative 1 isn't that positive 1? So it's just going to flip it across the y-axis. So with something like this, we'll just plug in points. Okay, here we go. Here's our first practice. So you'll want to pay attention to this. Here we go. So the first thing you do, identify your shift. Is there a shift left and right?
Yep.
So we're going right,
3.
right 3, okay? Now you're up and down.
Then 5. Down 5.
Right 3, down 5. Now understand, you're taking the origin. You know that this is the origin? Everybody, you know that's called the origin, right? You 0, 0, you're taking 0, 0, and you're shifting it right 3, down 5. So I'm going right 1, 2, 3, down 1, 2, 3, 4, 5. So I like to draw in, there's my new origin. And then we have a new asymptote. Didn't I say that it would be at this value?
Right.
Okay, we have our new asymptote. So now from there, plot a bunch of xy points. So let's treat this as the origin. So we're going to plot in points around the new origin. So let's plug in 3. Go. Plug in 3. Up here.
It's 3.
Oh.
Just plug it in.
Plug in 3. Where is the next? Do you guys understand why I'm plugging in 3? Because this is my new origin. I'm plugging in values around my origin. So I'm starting with 3. What'd you get?
8. Yeah.
You should have got -7. If you don't know how to type it in, let's all practice. Take your calculator, type in -2, parentheses 2, raised to the, you have to put the part that's being raised in parentheses. So raised to the, type in 3,
3.
raised to the 3 minus 3, and then -5. Type it in. What do you get? -7. So we're going right 3 down to -7. Now look.
I thought we were treating it like the origin, so how come we don't go right 3 from the origin?
No. We're just plotting points, right? Our function at 3 is at -7. At 3 is at -7. Now you could have thought of it like this. Isn't this our new origin? Didn't we usually plot our initial value?
Yeah.
And our initial value was -2. So didn't we go down 2 from there? But if you didn't do that, you could just plug in a bunch of values. Okay, let's plug in 2. What do you get? So you're doing -2 times 2 raised to the parentheses. 2 minus 3 minus 5. What do you get? Go, go, go. Type it in. -6. Okay? So we're going to go over to 2 down to -6.
Question.
Yeah.
Can't you only go right now because that's where the y is?
No, we can plug in a million. We can plug in any point on the x-axis.
They'll just get really small.
Yeah. So let's plug in 1. Let's plug in 1. So you're typing in -2 times 2 raised to the 1 minus 3 minus 5. What do you get?
-5.
-5.5. So we're going over to 1 down -5.5. Now if you keep typing in values, guys, it's going to get really close to the asymptote but never cross it. Now let's plug in 4. What do you get when you plug in 4?
What do you get?
-9?
Yeah.
So you go over to 4 down to -9, which is right
Also
there.
exponential.
So do you see now how it's exponential?
Yeah.
Is it ever going to cross the asymptote? Nope. Okay, let's do domain and range. So our domain is all real numbers, right? It's going from -infinity to +infinity. Range is y values. What y value did it? What's the lowest y value?
5.
I got fairness.
-infinity. And where did it stop?
Nerve.
Negative.
Zero.
Nope.
-5.
-5. Not including because it never crosses -5. Do we need to do another one like this?
No.
You're sure? Can you draw in your new asymptote? Okay, with this one, is there a shift left and right?
No.
Is there a shift up and down?
Yeah.
Okay, what about this one? Is there a shift left and right?
Oh.
Nope. Right? There's not. Nope. And what about, okay, do 7 through 12. Go. That's what's due at the end of the hour. 7 through 12.
Yeah.